Hey, what's going on? So, I'm going to introduce to you this topic: speed and average speed and velocity and that kind of stuff. Um, I'll probably introduce it in a way that's a little bit different than most other textbooks, or maybe not most other, but this textbook in particular. This topic happens to be something a little bit special to me, and so I want to make sure you understand it correctly um, and in a very specific way because you can apply that same ideas to harder problems. That's really important for me as well, for you to be able to do that. So I'm going to really probably go into a lot of detail in this first video, and I want you to make sure you take notes and all of that kind of stuff. All right. The first idea is a lot of times people interchange the words speed and velocity. And speed and velocity are two separate things. So I think that for the rest of this book, what you're going to be learning about is speed. And I'll teach you about velocity when we talk about physics one day. But for now, we're going to be learning about speed. So let's limit ourselves to that. The first thing that you need to know about speed is if I told you, oh, well, first of all, I need a good pen. Let me go grab that. All right, first thing you need to know about speed is if I told you how fast something was moving or how fast we drive on the freeway. Well, in Hawaii, we drive on the freeway on an average speed of 55 miles per hour. And if you look at the units of this, you can immediately it immediately tells you the formula for speed. What I like about this is you're probably used to hearing mom and dad talk about 55 miles per hour or 25 miles per hour or anything miles per hour when we're talking about how fast we're going in the car. It's because in America we measure distances as in miles and time as in hours. Some other places will measure it in kilometers instead of miles, and that's most of the European countries and pretty much everywhere else in the world besides America and Burma, apparently. Doesn't use miles, and so they'll use kilometers. So, you can interchange this miles or kilometers with whatever distance you want to talk about, but basically, we're talking about some kind of distance over time because hours is a measurement of time. I want you to understand this formula. Speed is equal to distance over time. There's a few variations on this formula, and they're not three different equations, but we can do a few things to it. First thing we're going to do is let's kill fractions. Let's kill that t downstairs. If I want to fight that t and get rid of it on that side, then I could just say, okay, well, let's multiply both sides by t. Got it? So I could say s times t is equal to d, because those get killed. Or distance is equal to speed times time. That makes sense. All right, I could do another one. I could do, let's get rid of this s. So I go, time is equal to distance over speed. All right, so let me erase this and write down the three equations that I came up with. Well, I don't even need to erase it. I've got speed is equal to distance over time. I've got distance is equal to speed times time. And then I have time is equal to distance over speed. And you think, man, I've got three different formulas to use and apply them. No. It all comes from one formula. Speed is distance over time. This is not a hard formula to memorize because you know that speed is measured in distance over time. So it better be a distance over time if you're measuring it in distance over time. So that's formula number one. This formula really just comes from messing with this first formula. And this last formula comes from messing with this first formula. So these aren't three different equations. This is just three different ways to write this first one down. Does that make sense? So I don't want you to freak out about the three different equations that you might see or, I might use. And I actually won't ever pull these two equations out and say, well, we're going to use that equation or number 2 or number 3. I'm always going to start off with this one. And then I'm going to figure out those other two equations. So you don't even need to memorize those other two. This is the only one that you really need to worry about. What this does is it sets up a ratio. Now I remember talking to you about ratios before, and I told you ratios are basically just fractions. Okay. So let's try this. "75 kilometers per hour" is what the first book tells us. So I write that as 75 km over h instead of writing out kilometers per hour. I'm just too lazy to write it down. This means that for every 1 hour, you go 75 kilometers. You have yourself now a ratio. This is a fraction. 75 kilometers divided by 1 hour is equal to 1 hour in this particular case. So I guess the question is, if you're going at 75 kilometers per hour and you go for 2 hours, how far do you go? All right, that question is pretty easy to answer on the surface, and let's answer it now. If I go 75 miles every hour, then in 2 hours I'm going to go 75 miles twice, which would be 150. There's your answer right there. We know how to do that because that's just 75 added to another 75. The more mathy way to go about that is this. If I have 2 hours and I want to figure out how many kilometers I go, then I'm going to multiply it by a fraction. I'm going to choose this fraction right here. The reason why I chose this fraction is because I know that 75 kilometers equals 1 hour. In 1 hour, I go 75 kilometers. Those are equivalent to each other, apparently, according to the problem that they told me. The reason why I multiply 75 kilometers on top and 1 hour on the bottom is because there's 2 hours in the numerator here. So I want to take this numerator, the units for this numerator, and cancel them out with the units in this denominator. This is what I'm talking about. This is going to be a very powerful tool for you. You're going to use this in physics, obviously, because this is the basics of physics. But you're also going to use this thing in chemistry and further mathematics and biology. These ratios is really important for you to understand. And it really all comes from this. So this hours cancels out with that hours. And I've got 2 times 75. And my units are kilometers because the hours canceled out with each other. So 2 times 75 is 150. So what would 3 hours be? Okay, fine. 3 hours. I want to multiply that by some kind of ratio. I'm going to choose 75 km over 1 hour. This cancels out with that. 3 times 75 is 225. 25. And that's your answer. All right, let's try another one. The book gives you a bunch of speedometers to read, and I'm not going to draw all of them up here and answer them, but I'll tell you the answers to all of them, and you can make sure that you agree with me. The first answer is 50. The second one is 65. The third one is 35. The fourth one is 90 miles per hour. The fifth one is 45 miles per hour. And the last one on the bottom right-hand side is 70 miles per hour. All right, let's do the problem number 2. A van is traveling at a speed of 50 miles per hour. So, S is equal to 50 miles for every 1 hour. How far can it travel in 2 hours? Okay. So I'm going to go with 2 hours. And I want to figure out exactly how far it travels. I'm going to choose a ratio of 50 miles for every 1 hour. This will cancel out with that. And I end up getting 100 miles. Notice actually the equation that I used. What I ended up using was 2 hours is time, this is speed, and this is equal to distance. I use this, what is this, like the second equation that I wrote down? Time times speed is equal to distance. I used that equation. I didn't tell you I was using that equation. That's the equation I ended up using. I really only looked at the units to figure out how to get to the answer. But yeah, that's the equation that we used. It's pretty straightforward. All right. Eric is swimming at a speed of 40 meters per minute. 40 meters for every minute. How far can he swim in 5 minutes? Okay, so 5 minutes. Set up my ratio. Here's my time. Multiply it by my speed, which is that ratio. So 1 minute, 40 meters. So 5 times 40, 200 meters. Apparently this kid can do a 200-meter swim in 5 minutes. All right, and then I need to go through, okay. A bullet travels at 420 meters in 2 seconds. Find its speed in meters per second. Okay, so a bullet travels 420 meters for every 2 seconds. If I'm asking you for the answer in meters per second, then really what I want is meters per 1 second. How do I make this, and then I don't know what the number is up here. How do I make this 201? Well, I divide it by 2. Well, what you do to the bottom, you have to do to the top. So I should divide this by 2. 420 divided by 2 is 210. So these ratios are the same. These fractions are the same. 420 meters per 2 seconds is the same as 210 meters per 1 second. This is probably the easier way to write things down. And usually we write this as 210 meters per second. I don't put that per 1 second on the bottom, but I do when I'm talking about it with you. Okay. Ravi is running at a certain speed. He runs a distance of 150 meters in 30 seconds. Find his speed in meters per second. Okay. So 150 meters in 30 seconds. I want to reduce this so that it's blank meters for every 1 second. Well, how do I get this 30 to be a 1? I divide it by 30. I should divide the top by 30 as well. 150 divided by 30 is 5. Yeah. So apparently, Ravi can run 5 meters per second. That's pretty much it. Keep in mind that this equation that I use is speed is equal to distance over time. So apparently I'm not even going to tell you which equation I'm using. I'm just going to look at the units and all of that kind of stuff. But I do want you to understand these things because I think it's really important.